Okay, I'm going to walk you through what you really should have on this here. This is lesson 3.1. You should have been working on it on Thursday and maybe even finished, but just in case you didn't, I'm going to kind of walk you through, and I'm going to try to add in a few things here. So the first thing I'm going to add in is let's get all of our formulas put down here. So here we go. I'm going to add in a little text here. And let's start with the slope formula. So the slope formula is equal to, we say m, it's equal to the change in y, right, delta y over delta x. So I'm going to write it y minus y and divided by x minus x. That's how we find the change in y and the change in x. Let me stretch that out a little bit. So that's your slope formula, okay? You're going to use that because you're going to want to calculate the slopes of all these sides here. Okay, and we'll explain why in a minute. The next one that you want to do is you want to know the distance formula. Alright, I can't type math so well on this tool here, but hopefully you'll be able to follow me. So you're going to start where the distance is equal to, so this is the side length, distance between 2 points, which in this case we have a quadrilateral in the plane, so between these two vertices, say C and D, what you're going to do is you're going to take the square root, so this all sits underneath the radical, okay? Everything fits under the radical. And all you're doing is you are finding the delta x, delta y, right? Because we're thinking about this right here being the hypotenuse of a right triangle. So you have a vertical leg here and a horizontal leg there, right? And we said this vertical leg right here represents delta y, or the change in y, the difference between 10 and negative 2, right? And this horizontal leg represents delta x, or the change in x, the distance between 9 and 14, okay? So what you're doing is you put it all into the square root sign to solve that hypotenuse. You put it in the square root sign and you say, okay, let's do x minus x and square that, and that means squared, okay? And then you're going to add that to the other leg squared, which is the vertical leg squared, y minus y, and square that, okay? And whatever you get, that's going to be that's going to be the distance between D and C here. You need to do that for all four sides. We're going to do this a whole bunch in this whole entire chapter, so you got to get really good at the distance formula. Now you don't have to calculate these by hand. You can use the calculator, plug the numbers in, and let the calculator do the calculating for you. Okay. Finally, we have the slope criteria. So slope criteria means that we're going to be able to use the slopes to figure out whether or not these lines are parallel or if they are perpendicular. So if they're parallel lines, right, with the slope criteria, the parallel lines, then we know the slope of line 1 is going to be equal to the slope of line 2. So if you think two lines like side AB and side DC are parallel, you need to just calculate their slopes. If the slopes are the same, then you have it perfectly. You got parallel lines, okay? Now, if they're perpendicular, to test if they're perpendicular, then what we do is we multiply the lines, okay, M1, oops, let me do that again, M1 times M2. And they should equal -1 when you multiply them. And that's because perpendicular lines have opposite reciprocals, okay? So if this slope over here looks like maybe it's going to be something like plus 12 over 5, it looks like to me. So if this was perpendicular, it would be down 5 over 12. So -5 over 12 for one slope and positive 12 over 5 for the other. And if that's the case, then this has been rotated exactly 90 degrees, and this is a right triangle. And that can just be, just a right angle rather. These lines are perpendicular, and this is a right angle. You have to test that, okay? You're going to have to test that in here quite a bit. So you'll have to calculate the slopes and the lengths for all the sides and write them down. You'd write down over here, AB, the distance of AB is equal to, and then you put that amount in there, whatever that is, okay? And then write it in there, CD is equal to, and write that in there and stuff. So as you're working on this, it's a good idea just to have that all calculated. And later on, they're gonna talk about that. We'll go through what you need to fill in. But I would encourage you just put these notes right on your page, okay, here. Write them in just like that. Make sure you have these in the front of your book as well. So we're going to use them a bunch. And then I would just go ahead and use the distance formula to calculate it. And then, after you're done calculating all the sides, then find the slope of AB and the slope of, CD and the slope of BC, whatever, all of them, right? I mean, you want to just find all that stuff. Find out what they are and write them down, and you may as well just do that, okay? Now, next, let's see, let me get this thing moved on. Here she says, Marissa's mom says, the room is obviously a square or a rectangle. If you can figure out the length of one or two sides, you can determine the area. That is not necessarily true. Marissa says you can't just assume a shape is a square or rectangle because it looks like one. She is correct. You have to verify that it actually is a square or rectangle. So the properties of each shape, well, squares, what do they have? Squares have equilateral, squares are equilateral, right? Which means the lengths of the sides are all equal. And the opposite sides are parallel. Okay? And then finally, all the angles, the interior angles, are right angles. Okay? That is the property, those are the properties of squares. Okay? Also, they have four sides. That's another thing, I guess, too. Quadrilaterals. Okay. Now, the properties of non-square rectangles, well, they are not equilateral, but opposite sides are parallel. Oops. And all angles are right angles. You know that? That's what this actually means. Rectangles, right? Right angles, that's really what this word means. So the test, if you have a rectangle, is to see whether or not all the angles are right angles or whether or not the sides are perpendicular to each other, okay? So here you're just supposed to be listing the properties. You don't have to actually do any calculations. Here it says, how can you use the properties to determine? Well, you're going to have to calculate the lengths and you're going to have to calculate the slopes. That'll let you know if it's a square or if it's a non-square rectangle, okay? Now, rule of thumb is that the maximum occupancy of a room is that each person in the room should be given 6 square feet of space. So what you have to do is you have to say, okay, she's going to need 36 square feet of space for each person she wants to bring to the party. Does it say how many people she wants to bring to the party? It just says all of her friends and their families, so you got to kind of figure that out. That could be, if she's got a lot of friends, if she's got 30, 40 people, I don't know. Maybe she doesn't have that many friends. But you got to figure that out, okay? And then you'll make an estimate. Each one is 36 square feet, so you take however many people you want to estimate that she's going to have, and you're going to multiply by 36. And then it says, describe the information you need and the strategies you could use to improve your prediction. Obviously, you'd have a better prediction if you knew exactly how many friends and family she was going to invite. And then the strategies you need to be able to use, the distance formula to get the side lengths and confirm that the images are either rectangles or squares so that you can then multiply length times width and get the areas, okay? So now this is where they want you to determine if it's a square or rectangle. You're going to do that by multiplication after you've determined the side lengths using the distance formula. Then it says use the rule of thumb to determine the maximum number of people. So you're going to have what the total area you found out above, which is one length times the other length, and then divide by 36. And he's telling you right here, he's kind of saying, it doesn't look like it's going to be much of a party. It doesn't sound like it's going to be. So you're going to have to find the area, but it sounds like maybe she's only going to have, a room for a few friends. Okay, next. Now we have this transformation. Sometimes it's best to use transformations. It can certainly save you some time. And this is an example of that. So we have two quadrilaterals that are together in a figure, okay? You can see these two quadrilaterals here. And so what you might do is just try to figure out, hey, are these both congruent? Okay, if you're congruent, then you only have to calculate one. You don't have to calculate both. It'll save you some time, right? So here it says, describe the information. Now it says you don't calculate anything yet. Just determine what you need and think about a strategy. Well, you're going to need to know the lengths, right, and the widths of each of these two quadrilaterals. And you got to know the slopes so you can figure out whether or not it truly is a rectangle. And once you have it proven that these are rectangles and lengths and widths, then you can actually see, are they congruent, and then you can figure out the total area. I mean, find the area of each one and add them together, right? But you might be able to do it even easier. Colby says that the two quadrilaterals are congruent. He says that if you know this, it can help him determine the area of the figure more efficiently. Is Colby correct? Well, yeah, I mean, if I already know the area of this is equal to the area of that, then I can just calculate one. I can just calculate KLMN, and once I've got the area of this one, I just double it, and that'll give me the area for both. So yeah, it's a little bit easier. I won't even have to mess with the other one at all if I know. Once I know that this rectangle here is truly a rectangle and what the dimensions are, I can figure its area. And if I know this is congruent, well, then I'm in perfect shape. I don't have to do it twice. Okay. It says describe a transformation you can use to determine whether the quadrilaterals are congruent. So you remember doing translations, where what we did was we looked and said, hey, how did we move, one point to another point in the plane? And you'd have to verify that each of these points got moved the same way. So this isn't that hard, actually. If you take a look here, we're lucky because point N is at the origin. So to move from N to J, we can see the Y value stayed the same, 0, 0. But the X value, we started N, we go to J, we subtracted 135. So remember how we wrote our translations? We can write it like this. We can just say, well, from X, we take away 135, right, and leave Y the same. And that could be a good way to describe the translation from N to J. Now what you have to do is verify, is that going to work from M to H and K to F and L to G? If that works, given these coordinates that you have here, that each one you can find, you can solve each one by just doing this, get the new point. So you'd start with like M right here, right? And then to find J, just take M, subtract 135 from 68.75, whatever number you have, and then leave Y the same. Are those the coordinates of H? And if they are, then this is translated exactly the same amount as this, and you just do the same thing for each of these. And that's how you can prove that they are congruent, because when you're translating an image, that's a rigid transformation, and all the properties are the same. So it says apply the transformation you described, determine if they're congruent, explain your reasoning. Tomas says when you have polygons that have vertices on the x or y axis that are at the origin or are on the origin, it's a little easier to use distance formula because one of the more of the coordinates are 0. Well, that's like we just did right here. By using point N that was at the origin, I didn't even almost have to use the distance formula because I could just see I'm here at 0, 0. I'm staying at 0, 0. This is a straight line, and all I've done is taken away 135. So I think Tomas is correct. You just kind of got to explain why he's correct. Make sure you explain that. And it says which quadrilateral would Tomas choose and why, and determine the area of the entire figure. So you need to get that done, okay? Now use the coordinate plane to draw a floor space, a floor plan for a space that she could use. It's going to start with these coordinates. You're going to probably need to make each of these lines equal to 5 or maybe 10. I think I'd probably do 5, right? If you place the origin in this corner, so that would be 0, 0, then you'd have 5, 10, 15, 20, 25. That'd be 25, and you go up 6, 5, 10, 15, 20, 25, 30. That's where the first point would be, okay? And then you'd find the other one, which is going to be up here somewhere, over 65, up 75, and that'd be one side. You need to now figure out, let's see, if you have 100 people and each one needs 36 square feet, that's 3,600 square feet. So you're going to figure out the length here, and to figure out the width, you take 3,600 and divide by the length. It'll tell you how long the width has to be. And then you can, construct a perpendicular line that goes up this way. Kind of tough, but I want you to see if you can get that done. And that'll be your challenge from 3.1 is to get that last problem done.